Hi, this is Chris. We are in SAT Practice Test 2, and we are taking a look at Section 4, questions 19 through 21. So 19 and 20 both refer to the following information. A sociologist chose 300 students at random from each of two schools and asked each student how many siblings he or she has. The results are shown in the table below, and we see the corresponding table showing the results from each of the two schools mentioned. There are a total of 2,400 students at Lincoln School and 3,300 at Washington School. Question 19 asks, what is the median number of siblings for all the students surveyed? Now, this question is very, very commonly missed when people focus on the results without including the frequency of those results. And the best take-home message that you can keep in mind whenever you're dealing with a question on median, which means middle, is that when you're looking at a frequency table like we see above, the frequency matters. It's very easy to forget that. So very commonly I see students when tackling this question, they look at the table and they look just at this column for number of siblings and they go cancel, 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 cancel. The middle value is 2 and they pick answer choice C, which is incorrect for this. So this is a mistake we are definitely not going to make on test day. Let's take a look at how we can use this tip that frequency matters. So they say in the description that the sociologist chose 300 students at each school. So that would be a total of 600. Now you could calculate that on your own by adding up all of the values that we see here to figure out that it was a total of 600 students surveyed, but that would be a lot of math. So if we use the information in the text, we can sometimes save a calculation step. So here we have 600 total results. And if we want to figure out where the middle term is, well, you could write them all out, and here you would say, okay, for 0 siblings, at Lincoln School it was 120, at Washington School it was 140, so you could write 0, 0, 0, 0, 0, 120 times for Lincoln School, and then keep on writing it, 0, 0, 0, 0, 0, another 140 times for Washington School. But we can see that that would be a lot of writing and a lot of time. So let's see if we can think of a more practical way of looking at this. Median means middle. Median means middle. So if we take a look at 600 total results, the middle result is going to be around the 300th or 301st result. And luckily, SAT is going to be very nice. They won't make you average the middle two results. For a number this large, you can just divide that by 2 and say, okay, we're looking for something around the 300th result. That would be our median value. So let's see what that 300th result in our list might look like. Now, instead of writing out each one individually, let's just use the information provided here in the table. And we're going to shortcut this a little bit. If there are a total of 260 students that had 0 siblings, then that means if we were to write out each one individually, we would write 0, 0, 0, 0, 0. We would write it 260 times. So that means that if you think of all the zeros that there are for your results, 0, 0, 0, we can put an ellipses in there, dot, 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 all the way to that final 0. This is going to be a total of 260 zeros, or that final 0 would be our 260th term, right? So now let's continue from there and see how many results of 1 that we have. How many of the students said that they had 1 sibling? And remember, what we're looking for here is we're looking to try to find what the value of this 300th term would look like. So if we look at our 1s, we can see in here that that's a total of 190 more results, which means that we would write 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 190 times. So in total, if there's 190 of those, that final 1 that we write, this would be, when we add together the 260 and the 190, that's going to sum to 450. This would be our 450th term. And this final 0, as we already said, that was our 260th term. So our 300th term, we know is going to fall somewhere in there. And we can see that we have so many ones in a row. We don't even have to worry about the number of terms and whether or not the median is going to be an average of the middle two, or if you're going to get an exact middle term. We know that no matter how you shake it, that 300th term is going to fall well within this grouping, which means our median value here is going to be a 1. And again, that is a very simple concept, that median means the middle value, but it gets complicated when you have a frequency table, and all that we want to take away is just make sure that you include this concept that the frequency definitely matters. So we need to make sure we take that frequency of result into account whenever we're trying to find that median value. Up next, let's take a look at question 20, which also pertains to this same data set. And here it says, based on the survey data, which of the following most accurately compares the expected total number of students with four siblings at the two schools? So expected total number. And here, if we look, we see that for 4 siblings, we have a value of 10 for each. And very commonly, people gravitate right towards answer choice A, which says that the expected number is expected to be equal. But what's really important to keep in mind here is that the numbers in our table, this is from our sample. And your sample results are not your expected total number of results. We have to apply that information from the sample to the population. So that's where these numbers below come into play, that we have 2,400 students at Lincoln School and 3,300 at Washington School. So we can't forget that expected total number, right? Total is going to take the entire population into account, and we have to see if we can figure out how do we extrapolate what that population value would be given our sample values. Well, let's look at each school individually. So for Lincoln, here, put an L for Lincoln, and here they had 10 students with 4 siblings, but that was out of their sample size. So let's refresh and see what they said for our sample size. The sample was 300 students at each school. So for Lincoln, they had 10 out of 300, but we have to translate that into how many is that going to be, or X, out of our total student population of 2,400. And from here, we can cross multiply and solve, and this will give us 300x equals 24,000 divided by 300. If it makes the math easier, you can cancel out a couple zeros. And when you cancel out 2 zeros from each, you get 240 divided by 3. X would equal 80. So there would be 80 from Lincoln School. And I'm going to make that a little bit smaller and move that over. Now let's take a look at the same type of calculation for Washington School. So here, again, same logic. We still had 10 respondents out of our sample of 300. But now when we look at the total number, remember, we're trying to figure out that total out of a different total number of students. Washington School has 3,300 students, as it says over here. So 10 over 300 equals x over 3,300. We still cross multiply and solve in the same way. That would be 300x equals 33,000. Cancel out a couple zeros. And 330 divided by 3 would give us 110. So now we can compare those values for each school, and the answer choice that explains that relationship correctly is the one that says Washington School has an expected value that is 30 more than at Lincoln School. Washington School had 110, Lincoln School had 80, so Washington School had 30 more expected total students with 4 siblings, and that's going to be answer choice C. All right, let's try question 21 to finish up this page. So here it says a project manager estimates that a project will take X hours to complete, where X is greater than 100. The goal is for the estimate to be within And that's a keyword here, within 10 hours. So it doesn't say exactly 10 hours, but within, meaning anything smaller than 10 hours is also okay, of the time it will actually take to complete the project. If the manager meets the goal and it takes Y hours to complete the project, so this is our actual time, and this is going to be our estimated time. Which of the following inequalities represents the relationship between the estimated and actual? So the difference here between our actual and estimated amount of time can be expressed as your actual, which is Y, minus your estimated, which is X. That will tell us what that difference is. That will tell us essentially how far off were we with our estimate. And they want us to be within 10 hours. And this is going to indicate that we have an inequality. So we can think that Y minus X should be less than 10, which might point us to answer choice D. And if we go ahead and pick that and move on, we might luck out and get correct. And that is correct on this. But in terms of comprehension, let's make sure we understand, where does this negative 10 value come from? Well, within 10 hours means that you could, in terms of your estimate, be over or under as long as you're within 10. So you could be over by, let's say, 9 or even 9.5 hours. You could be under by 9 or 9.5 or 9.9 hours, but we just have to be within 10. So you can think of this almost like an absolute value, that the absolute value of that result would have to be within 10. And whenever you do absolute value, remember that that's going to give you a range of results. This is the equivalent of saying that the positive version, Y minus X, is less than 10. But also the negative version, it has to be greater than negative 10 on the other side to account for that range of values. And this all stems back to the wording here of within. So within is a key word that lets us know that we have to find our expression, but then we have to be within both a positive and negative difference between those actual and estimated hours in order to find our correct answer, choice D.